All right, so your quiz, which is tomorrow, is covering R1 to R4. Okay, R1, we talked a lot about properties and vocab and stuff like that. You're not going to get quizzed on that. What you will get quizzed on is like basic operations. So, like order of operations, silly stuff like that. Obviously, it's not going to be as easy as like 2 plus 3 minus 5, okay? But you do want to remember the rules of order of operations. So, like, if you think about the M and the D, they stand for what? What does M and D stand for? Multiplication and division. Does that mean that multiplication has to come first and the division comes second? No, so that's the difference. So if I had something like 2 times 3 divided by -1, okay? I'm not supposed to do, well, let me actually reverse that. Let's do 3 divided by -1 times 2. Even though the M comes first, really I go left to right with that, right? Like the multiplication and division have the same weight, I just go left to right. So I have to divide by the -1 first to become a -3 times 2, which becomes -6, okay? Sometimes it doesn't change it, that order, and sometimes it does. So you want to just make sure that you go left to right with those. And then the same thing with addition and subtraction. You just want to make sure you go left to right with those. They hold the same weight, so you don't have to do the subtraction before you do the addition. I mean, the addition before the subtraction. Yeah.
Would it affect it if you did
This time I would have, yeah, you would have gotten a completely different answer, right? If I had done the multiplication first, I would end up with 3 divided by -2, which is -1.5. Totally different answer, right? This one's wrong. This one's right. So just be really careful. You also had in this section, like I think this was the section where you plugged in values in the expression. So you had stuff like if x equals -5 and y equals +2. And we had absolute value in this section, so it would have been like 2 times the absolute value of x minus y, something like that. And so you just take those values and plug them in. So that would be 2, absolute value of -5 minus 2. It's the absolute value of -5, 5, so that becomes 2 times 5 minus 2, or 10 minus 2, which is 8. So those should be relatively simple. Just be careful not to make a mistake. We also talked about the difference between this and this in R1. What's the difference between those two? What is the first one? What would be the answer there?
it was over
So this would end up being -4, right? That's the opposite of 2 squared, where the one on the right ends up being +4, okay? So when there's no parentheses, you want to make sure that it's the last thing that gets applied. This is read as the opposite of 2 squared. So the only thing that's squared there is the 2. And that's really like a -1 times 2 to the 2nd power. So you've got to do the exponent first and then take the sign. Whereas the second one, you're saying -2 is squared. So you're doing -2 times -2. So parentheses says keep it with it. No parentheses does not. We good on that? Yeah. And then, actually, I think that might be R2. R2 was the absolute value. And then we went, so this was, oops, so lazy. This is R1 and R2. Went to R3, which was all the stuff with polynomials. So this was adding, subtracting like terms. This was multiplying. And this is dividing, which you're not going to be quizzed on dividing. The good news. Okay, you will see it again. It'll be back, but you won't be quizzed on it. So this is, the easy stuff, like stuff like this, where If it's addition, you're just combining your like terms. So remember, with the exception of the coefficient on the front, it has to be exactly the same. So the negative 3x squared goes with the positive 2x squared, and that would be negative x squared. The positive 5x goes with the negative x, that would be a positive 4x. And the negative 3 goes with the positive 5, that'd be a positive 2. So change it just a little bit. Now you've got subtraction, but you also have multiplication going on there, right? So when I take that negative 2, biggest mistake people make is not distributing the negative with it to all the terms. So it's got to go to every term that's there. So this becomes negative 3x squared plus 5x minus 3 minus 2x squared plus 2x minus 10. And then combine your like terms. So negative 3x squared, negative 2x squared is negative 5x squared. Positive 5x, positive 2x, positive 7x, and negative 3, negative 10, negative 13. Questions on those? And then we add like just multiplication, 2x. Something like that. So this is a monomial being multiplied into a binomial. This gets multiplied into each one. So I do the coefficients first. Negative 5 times 2 would be negative 10. X to the second times x to the first. So when I multiply, I add the exponents. There would be 3 x's there, so x to the third. And then there's no other y, so it would stay as y to the first. Negative 5 times negative 3 becomes a positive 15. There's no x to multiply by, so the x would stay squared. And now I've got y times y, which is y squared. Alexis.
Wait, why is it become an issue?
Because it's negative 5 times negative 3.
Oh,
So you keep the signs. Questions on that one? Okay, then we had multiplying like 2x minus 3y times 4x minus 5y. So now you're multiplying a binomial by a binomial. This is where your foiling came in. So first would be 2 times 4, which is 8. X times x is x squared. Outer 2 times negative 5, so negative 10, and then there's an x, and there's a y. Inner would be negative 3 times positive 4, negative 12, and there's an x, and there's a y. And then last, negative 3, negative 5 is positive 15, and there's 2 y's, so y squared. God bless you. And then from there, combine your like terms. So there's 2 with an x and a y. What would you do if now there was more than just the 2 variables? So your foiling kind of expands. So this one I've got a binomial times a trinomial. I could have a trinomial times a trinomial, okay? You could have 4 terms times 4. All that doesn't matter, okay? The process is still the same. So I'm going to take this first term here, I'm going to multiply it times each of the terms inside the second set of parentheses. And then I'm going to do the same thing with the 1, multiply it times each one inside the second set of parentheses. So all right, so I'm going to multiply the 2x. So 2x times x squared would be 2x to the third. 2x times a negative 3x is negative 6x squared. 2x times 5 is positive 10x. And then I want to repeat the whole process for a positive 1. So 1 times x squared is x squared. 1 times negative 3x is negative 3x. 1 times 5 is a positive 5. If there was a third term here, if this said 5x squared, then I would distribute the 5x squared to each of the three terms and then combine my like terms at the end, okay? So for every term that's in the front parentheses, you would multiply it times every term in the second one. And then in the end, combine like terms. So there's only 1 cubed, so x to the third stays by it, 2x to the third stays by itself. Then I've got a negative 6x squared and a positive x squared, so that's a negative 5x squared. A positive 10x and a negative 3x, that's a positive 7x. And then the positive 5 is the only constant that stays by itself. Raise your hand if you got it right. Good. Just be super careful. Do not underestimate being careful on this stuff. Don't try to do the stuff in your head and then get it wrong because you just got sloppy. Okay? Be careful. All right, the last... The shortcut, you're asking?
No.
Okay.
I just got confused with the last one since I heard like 3 terms.
Is in this section would have been like something like this squared. Is this the same thing as saying 4x squared plus 9? No. Most common mistake of people just like cannot get that through their skulls. It's not the same thing. You have to expand and FOIL. So this is 2x minus 3 times 2x minus 3. And then you can FOIL 4x squared minus 6x plus 9. To get this. Or you can use a shortcut. Square the first term. So the square of 2x squared is 4x squared. Square of 2x is 4x squared. Square the last term. The square of 3 is 9. That's the last term. And then multiply the two together and double it. 2 times a negative 6x would give me this negative 12x. So you can use a shortcut if you remember it. Okay, but when in doubt, expand it and FOIL it out. What if this 2 was a 3? Then what? There'd be a whole another parentheses. So I'd take whatever I got from here and multiply it in to each of those terms. Okay? So just make sure you can read all that stuff. Leah?
But for the last question that we had, like,
4 or R.3, no, R.4, sorry, was factoring. So all the different types of factoring. Factoring out the greatest common factor. So if I had something like that, 14x squared y plus 28xy to the third minus 21x to the third y to the second. It's not going to say factor out the greatest common factor. The directions are just going to say factor, so you've got to look at them. Remember, the first question you always want to say is, can I take something out? So numerically, just on the coefficients, is there a number that goes into 14, 28, and 21? It would be what? 7, so I can take out a 7. Is there an x on every single term? Yes, so I take it to the lowest exponent that's there, so it would be x to the first. And then look at the y. Is there a y on every term? What's the lowest exponent? To the first. So then I take and divide each of these by that term. So yes, you can do this in your head. I'm going to just kind of show this step out so that we're careful. I would take and divide each of those by the term that I put on the outside, but you have to have this term on the outside. It's not gone. It's just being pulled out from it. So 14 divided by 7 would be 2. X squared over x would leave you just 1x. And then the y's would cancel out. Plus 28 divided by 7 is 4. X to the first, and the bottom and the top cancel out. Y to the third and the top, y to the first and the bottom leaves you with, good, y squared. And then there's a minus here, you don't lose it, negative 21 divided by 7 is 3. X to the third and the top, x to the first and the bottom leaves you with x squared. Y to the second and the top, y to the first and the bottom leaves you with a y. Yep, Evan. What can it be used for? Well, eventually you can solve these. So you would factor to solve polynomials. That's like the next step in them. And then finding zeros on a graph. I mean, there's lots of stuff for it, but that would be the next progression, is then take that and solve it. So if it said equal to 0, then you would try to solve it. All right, then we got into like, if it's 4 terms. I'm really bad at coming up with factoring by grouping in my head, so let's make sure this works. All right, so if we've got 4 terms, right, then I assume we're going to factor by grouping. So I want to group these together. I would want to factor out the greatest common factor from each set of parentheses. So from that first set of parentheses, what can you take out? A 3 and an x, and then it would be x minus 2. From the second set of parentheses, you could take out a what? A 5 and a y. So it would be a positive 5y, and then left over would be an x and a minus 2. And then what's inside the parentheses should be the same. And what's left over gets grouped together. Okay, then we had difference of 2 squares, so something like 36a squared minus 49b squared. If they're both perfect squares and there's a minus between them, it's called the difference of 2 squares. So usually if there's 2 terms, that's what I would check. Obviously check first, can I factor something out? And then after that, if there are 2 terms and they're both perfect squares with a minus between them, then I would square root the first term. So 36 square rooted would be 6, a squared would be a. Square root the second term, square root of 49 is 7, square root of b squared is b. And one gets a plus and one gets a minus. Remember, every single one of your factoring questions can be checked. You could take 30 seconds to multiply it back out and make sure you get your question. If you do, then at least you know you're right. Then we had like perfect square trinomial, so like 25a squared so now there's 3 terms, and the first and the last are perfect squares. So if it's that, you want to test to see if it is. I would square root the first, square root the last, multiply them and double it. If it equals your middle term, then it's a perfect square trinomial. So square root of 25a squared is what? 5a. Square root of 16 is 4. 5a times 4 is 20a. If I double that, I get 40a. So I'm not worried about the sign yet. I just want to know, does it equal the number in the middle? And it does. So then when I factor it, I square root the first term, which we already did. Square root the last term, we also did. Take the sign from the middle, so that's where it comes into play. Put it in the parentheses and square it. Then we had the simple ones, right? 3 terms, not perfect squares. So the first one's a perfect square, but not the last one. So I'm just looking for the factors of the last number that sums to the middle. So if it's a negative 8, I know one's got to be positive, one's got to be negative. I could have 1 and negative 8, negative 1 and 8, 2 and negative 4, negative 2 and 4. Which of these is going to sum to negative 7? This first one, positive 1 and negative 8. Again, can be checked, right? FOIL it out, see if you get your question. God bless you. Okay, and then we had where there's a number on the front. We said there was 2 ways to do these. You can either trial and error, set up your parentheses, take the terms of the first one. So this would be a 2x and an x here. Try the first and the last terms being terms of the 4. So I could try 1 and 4 and 2 and 2 until I get the combination that the outer and the inner work. So I can do 4 and 1, multiply this. I'd get 2x plus 4x, which is not 6x. So then I can switch it, 1 and 4. And this time I get 8x plus 1x, which is 9x. So that's the combination that works. Or I multiply first and last. So 2 times 4, I get 8. Find the factors of 8 that sum up to 9, which would be 8 and 1. Plug those in with x's after them. In for the middle term. And then there's 4 terms, so I factor by grouping. The parentheses are the same. What is in this spot? What's in front of that x plus 4? There's really a 1 there, so I get 2x plus 1. So notice this is the exact same thing as this, except the order switch. It's still the same thing, right? Multiplication, the order doesn't matter. As long as the 1's in the parentheses with the 2x and the 4's in the parentheses with the x, you're good.
Wait, why'd you do like the 2 and then parentheses 4?
So that's the other, God bless you, that's the other method to factoring when the term on the front is not a 1. Multiply first term and last term, find the factors of that sum to the middle term, and then replace it. So it's up to you which one you're more comfortable with. Obviously, if you're comfortable with both, there are perks to bouncing back and forth. Like if I had, like a 2x squared and then a 3x and then like 7x, let's just say, something like that, right? 2 and 3 are both prime. I'm only trying out 2 options there, really. Maybe I have to switch the order, but there's not a whole lot of options. If my first term is a 12 and I have to try 12 and 1, 2 and 6 and 3 and 4, or there's a 24 there and I have to try 1 and 24, 2 and 12, 3 and 8, 4 and 6, then obviously the second method's going to be a better option for you. But if you just rather, trial and error or that second option, it's totally up to you. All right, questions? Alexis.
Is that what I got this? But just like, like that project that we did?
Oh, yeah.
You know,